Okay, you're most welcome to this lesson. My name is Chimuli Robert, and today we are going to look at properties of quadrilaterals. But we need to know what are quadrilaterals. Note, we need to know quadrilaterals. Quadrilaterals are four-sided figures. Quadrilaterals are four-sided figures. And examples of quadrilaterals. Examples of quadrilaterals. Examples of quadrilaterals we have one. We have a square is a quadrilateral. We have a rectangle is a quadrilateral. Rectangle is a quadrilateral. We have a parallelogram. Parallelogram is a quadrilateral. We have a rhombus is a quadrilateral. A rhombus is also a quadrilateral. We have five. We have a kite is a quadrilateral. A kite is a quadrilateral. Six, we have a trapezium. A trapezium is also a quadrilateral. So we are going to look at, I've said quadrilaterals are four-sided figures, and they have varying properties. They do have varying properties. So that's what we're going to look at. We're going to look at the properties of a quadrilateral. How do you look at a figure and then you call it quadrilateral? So first of all, we shall start with a square. We shall start with a square. We are going to start with a square. So we need to see how it looks like. A square looks like this. Illustration. A square looks like this. That is a square. That is a square. Let us look at all the properties of a square. One, all its sides are equal. All its sides are equal. All the sides of a square are equal. Now, using our diagram above, that is to say, side AB, side AB is equal to side BC, is equal to side CD, is equal to side BA. Meaning that all the sides of a square are equal. Then we go to the sides. Another property. Opposite sides are equal. Opposite sides of a square. Opposite sides of a square are equal and parallel. They are parallel to each other. Parallel lines are those lines that run in the same direction and have equal distance between them. So opposite sides are equal and parallel, i.e. side A side B, side AB. Side AB is parallel to side BC. Side AB is parallel to side BC. And side AD is also parallel to side BC. So opposite sides of a square are equal and parallel. Then we go to the angles. All its interior angles, interior means inside, all its interior angles are 90 degrees. All its interior angles are 90 degrees. You can look at the diagram. All the angles are 90. All interior angles are 90 degrees, i.e., that is to say, angle A is equals to 90 degrees. Please, this is a symbol for angle, comma. Angle B is also equal to 90 degrees, comma. Angle C is also equal to 90 degrees. And angle D is also equal to 90 degrees. All the angles are 90. All the four angles inside are 90 degrees. Another property. We are saying the center angle. If we are to draw in the center angles, each of the center angle is 90 degrees. Each of the center angle of a square is 90 degrees. So when the diagonals meet, they form a center angle. So we are saying each of the center angle is 90 degrees. That is another point. Its center angles, are 90 degrees. Its center angles are 90 degrees. Okay, we continue with the properties. Continue with the properties of a square. Still continue with the properties of a square. So we go to the next part. We are saying diagonals are equal. Its diagonals are equal. Its diagonals are equal. Remember, we are still looking at the properties of a square. Its diagonals are equal. Its diagonals are equal, i.e., that is to say, diagonal AC is equal to diagonal BD. Diagonal AC is equal to diagonal BD. Its diagonals bisect each other. Its diagonals, to bisect is to divide into two equal parts. Its diagonals bisect each other. Bisect each other at 90 degrees. To bisect is to divide into two equal parts. As the diagonals meet to divide themselves into two equal lengths. Remember, we said the diagonals are equal. The diagonals, we said diagonals are equal, and as they meet, they bisect each other. They divide themselves into two equal lengths. So meaning that the distance from here up to here is equal to the distance from here up to here, is equal to the distance from here up to here. So the diagonals are equal. So that is what we mean. So I think those are enough properties of, those are the properties of a square. Now we are going to look at the rectangle. at the properties of a rectangle. Properties of a rectangle. Properties of a rectangle. Properties of a rectangle. So now our number 2 is going to be a rectangle. Our number 2 is going to be a rectangle. So number 2 is going to be a rectangle. Rectangle. Illustration. Illustration. So we draw a rectangle. This is our rectangle. This is the rectangle. A, B, C, and D. Okay. We are looking at the properties of a rectangle. 1, property number 1, its opposite sides are equal. Its opposite sides are equal. The opposite sides of a rectangle are equal. So that is to say, side AB is equal to side BC. Side AB is equal to side BC. These two opposite sides are equal. And I think you can see the markings. Here there are 2 bars and 2 bars, meaning that these two opposite sides, side BC and side AB, are equal. Then we also have side AD is equal to side BC. So opposite sides of a rectangle are equal. Then we go to parallel. Opposite sides of a rectangle. Opposite sides are parallel. Opposite sides are parallel. Opposite sides are parallel. Opposite sides of a rectangle are parallel. I.e., side A, I forgot to indicate parallelity, so opposite sides are parallel. So meaning that side AB is parallel to side CD, and side AD is parallel to side BC. So opposite sides of a rectangle are parallel. Now we go to each of, we are saying this side is parallel to this side and this side is parallel to this side. So each of its interior angle each of its interior angles is 90 degrees. Each of its interior angles is 90. This is 90, this is 90, this is 90. And that is 90. Now, diagonals are equal. Its diagonals are equal. Diagonals are equal. That is to say, i.e., diagonal DC, DB, diagonal BD is equal to diagonal AC. We have said its diagonals are equal. Then, so its diagonals bisect each other. Its diagonals bisect each other. Its diagonals bisect each other. To bisect is to divide into two equal parts. To bisect is to divide into two equal parts. So that is a rectangle. So please, you can observe and see. What do I mean? You have said its opposite sides are equal, meaning that when we say its opposite sides are equal, so this side is opposite this one. This side is opposite this one. And we are saying its opposite sides are equal. That is to say, side AB is equal to side BC because these two are opposite each other. Then we go to the next property. We have said opposite sides are parallel. Opposite sides of a rectangle are parallel. So i.e., or that is to say, side AB is parallel to side CB. You are seeing these arrows here. There are two arrows and two arrows. They are saying these two lines are parallel to each other. And what are parallel lines? Parallel lines are those lines that run in the same direction but will never meet. Those are straight lines that run in the same direction and will never meet. And they have the same distance all through as you prolong them. They have the same distance between them. Okay, now, we go to a point, that is why we are saying IE. Line AB is parallel to line BC because they are running in the same direction. And line AB is also parallel to line BC. Instead of writing the word parallel, I'm using the signs that represent parallel. Now we go to the next point. Each of its interior angle is 90 degrees. Each of the interior angle is 90 degrees. Each angle is 90. This is 90, this is 90, this is 90, this is 90. All the four angles, each of them is 90 degrees. Now, its diagonals are equal. The diagonal, the distance from here up to here is the same as the distance from here up to here. These are the diagonals. The diagonals are equal. So that's why I've said, that is to say, diagonal BD is equal to diagonal AC. Are we together? So now we have said its diagonals bisect each other. To bisect is to divide into two equal parts. When the diagonals meet, they divide themselves into two equal parts. I think there we are through with a rectangle. So we look at another quadrilateral. Another quadrilateral is going to be a trapezium. Another quadrilateral is going to be a trapezium. Another quadrilateral is going to be Atropisia. So we look at Atropisia. That is number 3. Atropisia. Illustration. So we are looking at Atropisia. And what we are going to look at is the isosceles trapezium. Okay, this is a trapezium. We start on a trapezium. The first property, we are saying two of the sides are parallel but not equal. Two of its opposite sides. Two of its opposite sides are parallel. But not equal. Two of the opposite sides of a trapezium, this is what we call an isosceles trapezium. Two of its opposite sides are parallel but not equal, i.e., the two sides that are parallel I'm talking about is AB. Side AB is parallel to side CB, but they are not equal in length. In isosceles trapezium, in the isosceles trapezium, the base angles are equal. In the isosceles trapezium, the base angles are equal. And we are saying in the isosceles trapezium, the base angles are equal. So, i.e., that is to say, angle A is equal to angle B. These two angles, these base angles, these ones, they are equal in the isosceles trapezium. Because this trapezium is isosceles, this one we are looking at is isosceles. Now, in the scalene trapezium, in the scalene trapezium, the angles are different. The angles are different. So now this is the isosceles trapezium. The scalene trapezium is different. So now I'm about to end. So diagonals are equal. Diagonals are equal. If the diagonals are equal, that is in the isosceles trapezium, the diagonals are equal. Meaning that, i.e., diagonal SC is equal to diagonal BB. Last point, diagonals do not bisect. Diagonals do not. For the diagonals do not bisect. They do not bisect. They do not bisect each other. What do I mean by this statement? When I say diagonals do not bisect each other, it means that they do not divide themselves into two equal lengths. They do not bisect themselves, divide themselves into two equal lengths. So this is what we call the isosceles trapezium. The scalene trapezium looks like this. This is what we call the scalene trapezium. That one. But now here, the diagram, this is the diagram of the isosceles trapezium. So now we have looked at properties of quadrilaterals. We have remained with a few quadrilaterals which we are going to look at next time. So we have looked at the properties of a square, properties of a rectangle, and properties of trapezium. Otherwise, thank you so much for watching this lesson. We'll meet next time in the next lesson. Bye.